Vrei să pleci, dar numai ei. Numai ei. Numai ei. Chipul tău și dragostea din tei.
In this lecture, we're going to begin to talk about section 11.5 of Stewart's book, Alternating Series. And the main thing here is that for series that have a special property, that is the alternating series, there's a much easier way to tell whether or not they converge than the more complicated tests that we've seen so far, like the integral test and the comparison tests. So what is an alternating series? An alternating series is a series whose terms alternate between positive and negative. So they flip back and forth, either positive, negative, positive, negative, positive, negative, or maybe it starts negative and goes negative, positive, negative, positive, negative, positive. So let's give an example. Let's take the series that is a sum from n equals 1 to infinity of minus 1 to the nth power times n over n plus 1. So what does this series look like? Well, minus 1 to the 1 is minus 1, and then we get a minus 1 over 2. So minus 1 times 1 over 2 plus minus 1 to the 2 is 1, and then a 2 over 3, plus minus 3 over 4, plus 4 over 5, and so on. And the reason that this is alternating is because this minus 1 to the n flips back and forth between plus, minus, plus, minus. So whenever you see a minus 1 to the n power or minus 1 to the n plus 1 power or something like that, this is an excellent sign of an alternating series. Okay, just to give one more example, let's look at the sum n equals 1 to infinity of minus 1, let's say, to the n plus 1 this time, times 1 over n. Minus 1 to the n plus 1, when n equals 1, is minus 1 to the 2, which is 1. So we get 1 over 1 plus minus 1 over 2 plus positive 1 over 3 plus minus 1 over 4 plus, plus, plus. And let me just emphasize that we know that without this minus 1 to the n, this series diverges, because this is a p series with p equals 1. This is the famous harmonic series. So what about this series, where you have the same kinds of terms? You have this 1 over n everywhere, but now it flips back and forth, plus, minus, plus, minus, plus, minus. So I'm going to pause and erase, and then I'll tell you the alternating series test, which is the best way to tell whether an alternating series converges or diverges. What is the alternating series test? The alternating series test says that if we have an alternating series that's given by a sum from n equals 1 to infinity of minus 1 to the n times bn, where bn, these are a bunch of positive numbers, so that we really do know that minus 1 to the n times bn is flipping back and forth, plus, minus, plus, minus, plus, minus. If these bn's satisfy, bn is always bigger than bn plus 1. That means that the bn's are decreasing, and the limit as n goes to infinity of bn equals 0, then the series automatically converges. So let me just pause and emphasize. The divergence test says that if the limit as n goes to infinity of the things you're adding up is not 0, your series diverges. The divergence test does not say anything if all you know is the limit as n goes to infinity of the things you're adding up is 0. The alternating series test isn't quite the same, but it's close. It says if you have this minus 1 to the n times a bunch of positive numbers, and those positive numbers are decreasing, then all you have to do is check that the limit of these bn's goes to 0 to see that your series converges. Okay, so this is much easier than like taking an improper integral or finding some other clever sequence to compare your sequence and series to. So let's look at what it says in this example. So first thing, here we don't have a minus 1 to the n, but we have a minus 1 to the n plus 1. But that's okay. If your series starts plus minus instead of minus plus minus plus, It's the same because you could just think of this as this series is minus sum n equals 1 to infinity minus 1 to the n times 1 over n. You could just factor out one of these n plus 1s. So all you really need is minus 1 to the something. You need some function flipping back and forth, plus minus, plus minus. Okay, so now 1 over n, these are going to be our bn's. And we see that bn is decreasing because as n gets bigger, 1 over n gets smaller. And I mean, it's definitely true that the limit as n goes to infinity of 1 over n equals 0. So this converges by the alternating series test. That's all you have to check. Having this extra property of being alternating means that there's going to be so much cancellation between consecutive terms that the things you're adding up are much, 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 much smaller than they would be if you didn't have this alternating behavior. So one thing that I'll say is the alternating series test doesn't tell us what the series converges to. It just tells us that it converges. This series, it turns out, converges to the natural log of 2. And we'll actually see why that is the case, like how you can know that this series converges to natural log of 2 when we talk about power series representations of functions in the very last few lectures of the course. Okay, so I just want to give one more example, and that'll be the end of this video. So let's do this other example from the beginning of this lecture. So let's take the sum n equals 1 to infinity of minus 1 to the n times n over n plus 1, which we saw was this minus 1 to the 1. We got a minus 1/2, and then plus 2/3, minus 3/4, plus 4/5. Okay, so in this case, this is definitely alternating because of the minus 1 to the n. And these n over n plus 1, this is going to be our bn. And okay, bn is definitely decreasing. What do you think? Well, we have 1 over 2, then 2 over 3, then 3 over 4. So this is an alternating series, but we already know bn is not decreasing. So the alternating series test doesn't tell us anything about whether or not this series converges. So you can't automatically apply the alternating series test to any alternating series. I just want to emphasize that you really do have to check that your bn's are decreasing and the limit as n goes to infinity of bn is 0. In this case, what is the limit as n goes to infinity of bn? It's 1. The limit as n goes to infinity of n over n plus 1 is 1. It's not 0. So it doesn't tell you anything. Does this series converge or diverge? Well, it turns out you can see this much more easily just by the divergence test. Minus 1 to the n times n over n plus 1 is not converging to 0. Minus 1 to the n is flipping back and forth, plus, minus, and n over n plus 1 is going to 1. So as n gets really large, this is flipping back and forth between something very close to 1 and something very close to -1. So the limit as n goes to infinity of the thing you're adding up is not 0. So the divergence test says that this series diverges. So in the next video, we'll see some slightly more complicated examples of how to apply the alternating series test.